Here we go. We're on lesson 5-4. This is on page 352. You need to be following along, going through the examples with us. We're going to be talking about special systems. And when we refer to special systems, that indicates we have a system of equations, two lines again, and they are special because, well, one, they either do not intersect, which means there is no solution, no point that they share. We're going to refer to this as inconsistent. And these are vocabulary words that you need to have in your notes because they are on the quizzes and on the test. So, a parallel set of lines is inconsistent with no solution. The other one that we've talked about, and doesn't seem so special, but it is to me, what if two lines cross in exactly one point? Well, that's what we've been studying, right? In this case, we call the system consistent. Consistent. It has a solution, and it is also independent. These words are found in lesson 5-4, both on 352 and 353. Okay? So our special situations are this. Parallel. They don't intersect. There's no solution. We call that inconsistent. One solution. Here it is. They intersect. We call it consistent and independent. And the third situation is this. Imagine, if you will, I have my first line. And then I have a second line. And I have those two equations. But they look a little bit different. And I really can't tell what's going on. But I see one line exactly on top of the other. In this case, we have at least one solution. Well, we have way more than that. We have infinite solutions. Infinite solutions indicates that this is consistent again. So consistent means at least one. This is a consistent system. At least one solution. And we also call this dependent. This is a dependent system. The green line on top of the pink line. Now this is paraphrased nicely at the bottom of page 353. It's called Know It Notes. Those are worth your time. You should get those in your notebook. Well, what's going to happen when we see a system of equations and we're asked to solve it? I'm going to look at example 1, and it says we have the line y equals x minus 1, and we have the second line. It is negative x plus y equals 2. Well, what we want to do in the easiest case, the first thing we want to do is compare y-intercepts and slopes. I can see that the first equation has a y-intercept of negative 1 and a slope of 1. The second line I have to adjust slightly. I've got to get it into slope-intercept form. That means I'm going to solve for y, and I see x plus 2. In the second line, I see a slope of 1 and a y-intercept of 2. Well, here's the important part. The slopes are the same. They are parallel lines, and I can tell that they're not the same line because they go through the y-intercept at two different places. So these are two separate lines. They are inconsistent they have no solution. So we would say they are inconsistent. You guys go ahead and check it out, number 1, and show me your answer when you get it, and I'll let you know how you're doing. We're going to go on to example 2. Example 2 says, let's look at a system with infinite solutions, 2x plus 1, and our second line is 2x minus y plus 1 equals 0. Well, I see again that my top line is in slope-intercept form. So I'm going to go ahead and change the second line to slope-intercept form. And I see this. If I add y to both sides, I get y is equal to 2x minus 1. Y is equal to 2x minus 1. Y is equal to 2x, I'm sorry, that's plus 1. Good catch. Y is equal to 2x plus 1. We have exactly the same line, so therefore we know those are dependent, and we also say that they are consistent. They are the exact same lines. I want you guys to go ahead and check it out, number 2, and show me that solution when you get a chance. Now, what's going to happen in example 3? What's going to happen if we have a system of equations and it's not so easy to tell what's going on? Well, I see something. If I divide everything on the top by 2, I get y equals 1/2 x plus 1. If I do that here, down here, I want to put it into slope-intercept form. I'm going to add 1/2 x to both sides. I also see y equals 1/2 x plus 1. I see the identical line, so we can manipulate the equations algebraically to see if they are exactly the same. Part B, this is example 3, second part, part B. I see y is equal to 2 times x minus 1, and y is equal to x plus 1. Well, over here, if we simplify it, we see 2x minus 1. Nope, not 1. Must be late in the day. 2x minus 2, and y equals x plus 1. And if I look at those, I see my two lines, 2x minus 2, 1x plus 1, and I know this system to be consistent, meaning one solution. The reason being they have different slopes and different y-intercepts. You guys check it out, 3a through 3c, and show me those solutions.